All right, we're back. First and second derivative test. So in the last class, we talked about finding the critical points. And then we're going to look at point of inflection. For the critical points, we use the first derivative test. For the point of inflection, we use the second derivative test. These will help us how to graph better. First derivative test gives us min and max. Second derivative test gives us concavity. That means concavity means we're looking at this type of curve or this type of curve. So if the concavity changes, that means that's where the POI is at, point of inflection, and that's where the concavity changed, and that's what we use the second derivative test to find it. So let's do some example, like if f prime of x is greater than 0 for all x inside the interval a through b, then f is increasing. If f prime of x is less than 0 for all x above that, then f is decreasing. Now if f prime of x equals 0, then f is constant. Sometimes we find the min or maximum. So let's look at this problem. X equal x fourth minus 2x squared. Let's find the critical points. So let's look at first derivative. We get 4x to the third minus 4x. Set it equal to 0. To find the critical points, we get 4x equal x squared minus 1. So our critical points is going to be x equal to 0 or x equal 1. Now to find the minimum or max, so we write, this is plus or minus 1. So these are my critical points, and I want to know what happens. So we'll use the information that I just gave you, this information, to figure out if it's increasing or not. So I'm going to look at f prime and plug in any value over here. So we could technically plug in, let's say, f of this one, f prime of negative 1000. I don't care about what's the exact answer. I just want to know if it's positive or negative. And if I look at this original function right over here, and if I look at negative, guess what? This is still going to be negative right over here. That's all I care about. Next, I want to pick a number between -1 and 0. So we could do f prime of -0.5. And we use a calculator, and we'll get positive. And we use the same concept again. F prime of positive 0.5. We're going to get negative, and over here we get positive. So let's see what does that mean. So what it means is at the left side of -1, the graph decreases. Then at -1, it hits the minimum or maximum, and it goes up. From there, we could figure this out. This is the local minimum. And at 0, again, it hits the maximum, goes down. As you can see, it's negative, and it goes up. So my minimums are at those points, and that's my maximum right over here. So we could find those points. Like now we want to know what is f of 1, f of 0, and f of 1 to the original function. So if I plug 0 in, I get 0. We're plugging into this original function. If I plug in -1, 1 minus 2, -1, 1, yeah, -1. So my points are -1, -1, 0, 0, and 1, -1. So that's my minimum. That's my maximum. That's my minimum. All right, good. Now let's figure out. So another way in the homework, they're gonna ask you show me the interval where it's increasing, decreasing. So you say that from -infinity to -1 and 0 to 1, it's decreasing. From -1 to 0 and 1 to infinity, the function is increasing. All right. Now what we're gonna do next is second derivative test. What the heck is that? Now for the second derivative, we got the first derivative. Let's look at the second derivative. In this case, it's super easy. 12x squared minus 4. All right, now let's find POI. Those of you who are coming in right now, I'm not gonna have any more pop quizzes because of the misscheduling. We're not gonna, and you don't have to stay for my lectures anymore. And also, I'm gonna drop one homework and one pop quiz. Yeah, I'm gonna drop one pop quiz and one regular quiz. Lowest score. Now, again, point of inflection is we gotta find the critical point over here is 12x squared minus 4, so you get 12x squared equal 4x squared equal 2/6. So x is plus or minus this. So that's my point of inflection. Any question right now regarding the point of inflection? So over here, we got to plug it in f double prime of 0. Over here, we plug in f double prime of billion. And f double prime of negative billion. And I want to know if it's going to be positive or negative. So here's my function. And if I go positive billion, I get what? Positive. If I go 0, I get negative. Over here, I get what? I still get positive. So over here, the concavity, what the heck is happening with the concavity? So positive concavity means it's this up. Negative concavity means it's negative down. and this positive up. Now, can we try to graph this given all this information? All right, before I do the next part to this problem, ask questions. All right, so let's graph this sucker. Let's see if we could try to do that. What the heck? Okay. All right. What are my critical points? 1, 0, 0. All right, let's do it this way. -1, 0, and +1. What is negative square root of 2 over 6? What is that? Let me use the calculator right now. Oh, it's 0.57 roughly. So it's going to be roughly right over here. That's negative square root of 2 over 6, and right over and positive square root of 2 over 6. All right. What else do we know about this function? Let me write down the function right over here. Y equal x to the 4th minus 2x squared. Well, if you remember your Math 127, this is degree 4. So it's even degree, and because it's positive, both tail and will behave up like that. Well, we know our minimums are going to be -1. So one of the minimum point is going to be right over here. The other minimum point is going to be right over here. So minimum means is this is how the graph should look like. Let me use a different color. And that's going to be your maximum. Your graph will look like that. Also, what do we know? That at this point, and we could find the y value of that point. Let me just plug that in. What's the y value of that point? We're looking at f of negative square root of 2 over 6. Okay. 2 over 6 parentheses. Okay, to the 4th minus 2 times 2 over 6. I'm doing the calculation. What is that square? The point is, oh, it's going to be roughly somewhere over here. Point of inflection takes place roughly over here, -0.5. So that's where a point of inflection is going to change, roughly over here. I really don't care about the y value of the point of inflection as long as you get an idea where you have the point of inflection is happening. The reason Now we could connect the dot. The tail end behaves upward, and at the left side of the point of inflection, the concavity is up. Same as on this side of it, concavity is up. But from negative square root of 2 over 6 to positive square root of 2 over 6, I'm doing that again. The concavity is downward. And it matches our criteria right over here. You have your maximum, you have your minimum, and that's what your graph should look like. Whew. The first problem we did, a hard one. All right, let's do it again. For the min and maximum, I care about the y value. For the point of inflection, not so much. Let's try this one again. 27t minus t cubed. Graph it. I'll give you a little bit of time. Try to do that. We have the first derivative test. And then we have the second derivative test. Okay, try it. All right, so let's try this one. Let's figure out the critical points. We get 27t minus 3t squared. Set it equal to 0. 27 minus 3t squared. You get 3t squared equal 27. T squared equal 9. So t is plus or minus 3. So we have our two critical points. Now we need to figure out if they're positive or negative. Now, so we want to look at over here again, f prime of negative billion, f prime of 0, and f prime of positive billion. Right away, we know that if I plug negative billion, I get negative. F prime of 0, it gives me 27, 0. And over here I get what? I'm sorry. F prime of 0, it gives me positive, and then over here negative again. Now let's figure out what is F prime of negative 3 and F prime of 3 is. What's the Y value for that? You gotta plug it into the original function, guys. If you put it on the first derivative, you're gonna get 0. So you're gonna get negative 54 and 54. Yeah. So that's my critical point. And then what happens? Negative, positive, negative. That's my minimum, and that's my maximum. So max, minimum. Okay, we're almost there. Now let's look at the second derivative. From the F prime, we'll do second derivative. We get, oh, that's super easy. I get negative 6t, so t is equal 0. That's my POI. And I want to know, does the inflection point change? So we're gonna plug it in. Double prime of negative billion and F double prime of positive billion. So over here, if I apply negative, negative, positive, and over here is negative. So concave up, concave down. All right, so let's try to graph this. I hope you started. I didn't assign a lot of homeworks in the last 2 weeks. I hope you worked ahead. You will see a lot of homeworks due almost daily now. Now let's go back again. This function, f is all right. So since we got an idea, the min and max are like huge number. What I'm gonna do is I'm gonna make this as negative 10, 20, 30, 40, 50, 10, 20, 30, 40, 50. But I'm gonna make this as negative 1, 2, 3, 4, 5, 1, 2. Okay. All right. So my minimum is at negative 354, roughly over here. My positive is at this point, roughly over here. So that's my maximum. And here is minimum. What else do we know? This is an odd function. And odd functions will behave either this way or the other way. And since it's negative, it's going to start at the top and it will end at the bottom. So we need to connect the two arrows while finding the min and maximum. And we have the concavity change right over here. At the left side of it, the concave is up. And at the right side of the 0, it's concave down. And we're able to graph it. In Math 127, you have to find the x-intercept and the y-intercept. Because we're online right now, I'm not going to ask you to find the x or the y-intercept. Any question? All right, so let's do the same thing again, but we're going to do a really hard one. x minus 2 to the third. Graph. So first you have to do the first derivative. I'm going to do the second derivative. Go ahead. Good luck, guys. Try it. All right, so let's try it. So for this, first derivative would be, and we could use product rule. And then chain rule. And then if we could factor out x minus 2, square out. X minus 2 plus 3x. So we get x minus 2 square plus 4x minus 2. So my critical points are going to be 2 and 1/2. And if I look at it, 1/2 and 2, I assume you guys all have done that. We're just going to verify it. This is interesting right now. This is just one minimum. So one minimum, it goes up and up. So let's figure out what's the minimum point. Is 1/2 and negative 27 over 16. In terms of points, what is that? Which is 1.69. 0.5 and 69. All right, so now let's look at the second derivative. Let me simplify that a little bit better to do the second derivative. X minus 2 cubed plus, oh, what am I doing? I could just do this. So do the second derivative of that, product rule. I'm sorry, chain rule. And then we do the product rule. 4, and we could factor out 2x minus 2 out, and we're left with 4x minus 2 plus x minus 2. So therefore, now we could simplify that to find the POI. 5x minus 4. Wait a minute, did I make a mistake somewhere? I made a mistake. I guarantee you I made a mistake. Oh, there's that extra 2 there. Forgot that extra 2. So it's 4x minus 2 plus 2x minus 4. So now this will look nicer. 6x minus 6. There you go. So my POI are going to be x equal 2 and x equal 1. And let's look at the point of inflection again. You're going to get positive, negative, positive. So how do we graph a function? It has 3 points of inflection with just one minimum. So let's go back to the original problem. This is what? Even function. And leading coefficient is positive. So right away, let's do this way. 1, 2, 1, 2. So 1, negative 1. So right away, we know the minimum is, what do we say? 0.51, 0.69. 0.5, 0.51, 0.69, somewhere over here. That's the minimum. And your point of inflection changes where? At 1 and 2. So over here, it's going to be curved downward. Over here, it's going to be upward, upward. Well, it's an even function. That's going to start at the top and it's going to end at the top because the leading coefficient is positive. I have the minimum right over here. At the point of inflection, it will still be increasing, but look, the point of inflections, the concavity changes, and then it changes back again. So in your Math 127, you couldn't do this. Now we can do that. Okay. All right, let's try. Okay, let's try a hard one. Negative 1/3 plus x minus 2 over 3 graph. Go ahead, try this one, guys. Just find the y value for the critical point. You don't have to find the y value for the point of inflection. All right, let's try this one. First derivative, negative x squared plus 1. Set it equal to 0. Your critical points are plus or minus 1. That's super easy. A negative, positive, negative. So yours min, max. So negative 1, negative 4/3, and 1 comma 0. Min, max. What about the second derivative? We get negative 2x, so point of inflection is 0. You get positive and negative. What else do we know about this function? It's an odd function. Leading coefficient is negative, so it's going to start at the top, it's going to end at the bottom. So we could graph this super fast. 1, 1. So negative 1.3, that's my minimum. And my maximum is at 1, 0. Ooh, this is going to be interesting. But your point of inflection is over here. Ah, look at this graph. Okay, it's positive right over here, and then it's going to be downward. So look at the concavity. It's positive right here, and at that point the concavity changes and it goes downward, and yet it still satisfies the condition what we set, that since it's an odd function and it's a negative leading coefficient, it's going to start at the top, it's going to end at the bottom, and the concavity is positive over here while holding the minimum right over here, and maximum is right over here, but the concavity changes at 0. Okay, any other question? I will stop my lecture right over here. Go ahead, check your due dates. It has been updated. If you have any question, shoot me text.